Hello everyone. Today we will be discussing the quick solutions of All India Akash Test Series Test 1 Code A and B for 12 studying students, which was held on 9th June 2019. So let us start with question number 61, which says that if the sets A and B are defined as A equal to x comma y such that y equal to 2 raised to the power x, where x belongs to all real numbers, and B is also a set given, that is x comma y, such that y is equal to x square, where x belongs to R, then the number of elements in the power set of the set A intersection B is. A very simple questions from sets. So let's firstly draw the graph of both the functions, that is y equal to x square and y equal to 2 raised to the power x. Y equal to x square will be something like this, and y equal to 2 raised to the power x, that will be like this one. Here we have to take care that y equal to 2 raised to the power x will cut the graph y equal to x square at 2 points for x greater than 0 and at 1 point for x less than 0. So in total we have 3 points for which the graph y equal to 2 raised to the power x and y equal to x square are intersecting, which means that number of elements in A intersection B is equal to 3. Hence, number of elements in power set of A intersection B will be equal to 2 raised to the power 3, that is 8. So, answer of the question will be option number 4, that is 8. Next is question number 62, which says that if A, B and C are 3 sets, then A intersection B minus C union A intersection B delta C union A intersection B intersection C is equal to. So this type of question can be solved by Venn diagram. So let's make 3 sets here, that is A, B and C. So if we talk about A intersection B minus C, B minus C taking its intersection with A, that will be this area. Now talking about A intersection B delta C, A intersection B delta C will give us again this area and this area. Also, A intersection B intersection C, that will be this part, right? Now, we have to take union of these 3. So, we can say that our required area is whole this one. So, we have to tell from the options this part is equal to which set. Now, option number 1 says A, that is not correct. Option number B says A union B union C, that is also not correct. A intersection B union C, that is equal to the shaded part. So answer of our question is A intersection B union C. So option number 3 is the correct choice. Next is question number 63, which says that a relation defined on a set A equal to -1 to 1 as R equal to x comma y such that sine inverse x plus cos inverse y is equal to pi by 2. So we have to tell whether the relation is symmetric, reflexive or transitive. So firstly, let's talk about reflexive. For reflexive, we know that x comma x should belong to R. So if we put y equal to x, we will get sine inverse x plus cos inverse x equal to pi by 2, which is true for all values of x in the domain. So we can say that the relation is reflexive. Now, let us assume that x comma y is belonging to R. So, we have sine inverse x plus cos inverse y equal to pi by 2. Now, we can write sine inverse x as pi by 2 minus cos inverse x, and we can write cos inverse y as pi by 2 minus sine inverse y. So, this is given to be equal to pi by 2. 1 pi by 2 will get cancelled. So, we are left with sine inverse y plus cos inverse x equal to pi by 2, which means that y comma x also belongs to relation R. Hence, we can say that the relation is symmetric. Now, talking about transitive. For transitive, let us assume that x comma y belongs to R. So we have Sine inverse x plus cos inverse y equal to pi by 2. Also, let's assume that y comma z belongs to R. So we have sine inverse y plus cos inverse z equal to pi by 2. Now, what we have to prove? We have to prove that x comma z should also belong to R. So, for this we have to eliminate y. How can we eliminate y? Just add both the equations. If we add these two, we will get sine inverse x plus cos inverse z, sine inverse y plus cos inverse y, that will give me pi by 2. That can be cancelled with 1 pi by 2 on the right hand side. So we are left with, it is equal to pi by 2, which means that x comma z also belongs to R, which means that the relation is transitive also. Hence, we can say that the given relation is an equivalence relation. So, correct answer will be option number 4. Next is question number 64, which says that the set of exhaustive values of x satisfying the inequality sine inverse x into cos inverse x plus pi by 4 into cos inverse x minus sine inverse x is greater than pi square by 16. So, we know how to solve these type of inequations. We will convert cos inverse x into sine inverse x. So let's see what we will get. Sine inverse x multiplied with cos inverse x can be written as pi by 2 minus sine inverse x plus pi by 4 multiplied with cos inverse x can again be written as pi by 2 minus sine inverse x minus sine inverse x. So we have minus 2 times sine inverse x. So this is greater than pi square by 16. So solving this further, we can see pi by 2 sine inverse x will get cancelled with minus pi by 2 sine inverse x here. So we are left with minus of sine inverse x whole square plus pi square upon 8 minus pi square upon 16 is greater than 0, which means that sine inverse x whole square minus pi square by 16 is less than 0, which means that sine inverse x will go from minus pi by 4 to pi by 4. So we can say that x will go from minus of sine pi by 4, that is minus 1 by root 2, up till sine pi by 4, that is 1 by root 2. So from the given options, we can see that option number 4 is the correct answer. Next is question number 65, which says that number of ordered pairs x comma y, where both x comma y are belonging to all real numbers, it is satisfying the inequation mod x plus mod y plus mod x mod y plus 1 by mod x plus 1 by mod y plus 1 upon mod x mod y is less than equal to 6. A very simple question. See, we know that mod x plus 1 upon mod x is always greater than equal to 2 because mod x is always positive. This can be proved by applying AMGM inequality also. Also, we know that similarly mod y plus 1 by mod y is also greater than equal to 2. Also, mod x mod y plus 1 upon mod x mod y is also greater than equal to 2. Now, if I add all these three, so we will get mod x plus mod y plus mod x mod y plus 1 by mod x plus 1 by mod y plus 1 upon mod x mod y is greater than equal to 6. But in the question, it has been given that it is less than equal to 6, which means that this is equal to 6. Now, this is equal to 6, which means that mod x plus 1 by mod x is equal to 2. Similarly, mod y plus 1 by mod y is equal to 2. Also, mod x mod y plus 1 by mod x mod y is also equal to 2, which means that value of mod x is equal to mod y is equal to 1, right? So we have to find the number of ordered pairs. Number of ordered pairs will be 4, and that will be 1 comma 1, minus 1 comma minus 1, minus 1 comma 1, and 1 comma minus 1. So we can say that number of ordered pairs are 4, which means that correct answer is option number 3.